Okay, today you should have two sheets. You should have a packet that has a bunch of word problems on each page, and then a problem solving guide. And this is kind of what we're going to be on today. The back side we will not use until later. And the reason we make this is because to be decent at solving story problems in algebra, you need to know how to map out a plan. Now, some of the problems might not require the plan, but as they get more complex, it's nice to have a go-to strategy if we can recognize when to use those specific strategies. It kind of makes story problem solving a lot easier. Okay? A lot of people do story problems. They're like, well, I don't even know where to start. Well, this kind of gives you a guide. Okay? And today we'll be solving a story problem where there are two significant units. Okay? Here's the first problem. This one's pretty easy. A lunch account starts with $60. Every day I eat, $2.75 comes off my balance. After how many days will my account be at $18.75? Now, so we're finding the number of days it's going to take. That's the unit that the answer's in. So the first thing I do, I'm going to make three boxes, okay? This is the first box here. It's called the rate of change in the units box. Okay. So I'll make a box like that. Now the two important units we have are the days, obviously, because that's the answer to the problem. That's the unit or the label of my answer. Put equals. And the other unit we have is dollars. Okay, that's also an important unit. That's a unit that's changing. So dollars. Okay, now, one of these is going to be our x represented by the x variable, and the other is going to be represented by a y variable, but it needs to be the right one, okay? And the way to know that is x is your independent variable, that's your independent unit, and if you have a time unit, which we do, because days is a time unit, that's going to be the x, okay? If you have a time unit like days, minutes, months, hours, anything that's a unit measurement of time, we need to go ahead and make that our x variable. And then money will go ahead and be the y variable. Okay? Now the next thing we want to do is try to come up with a rate of change. Okay? So rate of change is usually represented by the word per. And what you want to do is it's always the y unit over the x unit, okay? So our y unit's dollars and our x unit's days, dollars per day. Now you see this the slope formula there, but you don't use that unless you have to, okay? Don't use that unless you have to. Okay, now what's the dollars per day? Every single day, what's the rate of change for the dollars? What's happening to your money every day? Well, 275 is coming off the balance. So the dollars per day would be negative 2.75. Now it's negative because it's coming off. Okay. All right, so we don't really need to use this because I was able to identify a rate of change. Okay. Now, so that's pretty much done in that box. The next box, what I do is I make a graphic representation of the two units, and it's going to be a line. Now the reason it's going to be a line is because every day the money's coming off the account, okay? So I like to make a line. Now technically this line should go down because the rate of change is negative, but I always just kind of make it go up because I don't want to confuse myself and have to worry about that from problem to problem because it really has no significance in the end, okay? And here's how you set up your line. Three things you're going to put. You're going to put an x comma y coordinate point at the beginning, and the x will always be the x unit will be always equal to 0. So our days at that point are 0. No days have gone by. And then I put a little plus sign because on a line you're just adding something repeatedly to it. And then my rate of change term is represented by mx. Okay. mx, and then I have just a y up here, okay, and that's kind of how that is going to shake out. And that's what you're going to put every time, as long as you're able to identify a constant rate of change. It's a line. Okay, so the first thing we do is we're going to scribble out the M, because I'm going to replace that with negative $2.75. So negative 2.75x. Now the next thing I need to come up with is before we had any days, when the days were 0, before any days had passed, how much money did I have to begin with? $60. Okay. Now the y equals m dot x plus b, y equals mx plus b, that is used if I don't know what the beginning is at. Okay. And you'll need to identify a combo of the two units, but we don't need that here. Okay. So that's filled out. As soon as I know the rate of change in the beginning, I'm good to go there. And next what we're going to do is write an equation from this line. And it's really easy. How much did you begin with? You began with $60. And then you're going to add negative 2.75, but since that happens every day, we need to put the x variable onto it, because times x, and then equals the y variable. Okay, and that's the equation. Now, what we're going to do after that is replace one of these variables to solve the problem. So I've used the $60 as my beginning. I've used the 275 as my rate of change. We need to put that $18.75 somewhere. Now, what's its label? Its label's dollars, so dollars is y. So that's going to go in for the y, okay? All right, so I can just replace the y variable here, okay? So 60, because this is the one I'm going to replace. 60 plus negative 2.75x equals 18.75. And now I can solve for x pretty easily. Okay, now the x isn't by itself. We need to get it by itself by circling. Here's the x. Its coefficient is negative 2.75. I'm going to need to undo the 60 by subtracting from both sides. And I have negative 2.75x. And then 18.75 minus 60. Negative 41.25. Again, trust the process, and then divide both sides by your coefficient. Negative 2.75, negative 2.75. And then we have x, negative 41.25 divided by negative 2.75, and I got 15. Okay. Okay, so we have 15 days. Okay, my next problem. A fitness center charges $45 for a membership plus a monthly equipment usage fee of $7 per month. If someone would have paid a total of $87, for how many months would they have been a member of this gym? So again, there's two units, the dollars and the months. Those are kind of the two units, the labels and units that change. So the first thing, I make a units box, and months is my answer to the problem. That's what I'm trying to figure out. And then the other unit that goes with it is the dollars. Because that's how real life works. A lot of times it's two unit when you're using math to solve kind of complex problems. Now, if there's only one unit in a problem, really it's just adding and subtracting. You know, you don't really use all this stuff. But when there's two, that's what algebra is about. It's two or more units working together in the real world. Okay, so months is X, money's Y. Okay, because again, the time unit is always our independent unit, the X unit. X is usually the independent variable, and then Y is going to be the dependent variable. Okay, because the money you have to pay is dependent upon the number of months you go to the gym for. So per, and remember on the per ratio, we want to put the Y unit on top. Okay, so dollars on top, months on bottom, dollars per month. Okay, now what's the dollars per month? How much money is it changing by every month? Well, $7. Okay. All right, so we're done in that box. I did not have to use the slope formula to calculate this. Okay, so now I'm going to make a graphic representation. Again, it's a line because every month is by a constant amount, $7. The rate of change is constant. Okay, so we have a beginning point represented by X and Y. So at the beginning point, the X is equal to 0. That means that's since X is our months, that's before any months have gone by. Okay, and from there we're going to add the rate of change term, mx, and then y. And we know what our m was from over here, 7. Okay, now how much money did we have before the $7 per month? Before any months took place, we had to pay our membership fee, which is $45. Okay. Okay, so I'm good to go. I know the two things I need to know to write the equation. So I have 45 to begin with, $45, you got to pay that to begin with, plus $7 per month, so 7x equals y. Okay, now we need to replace. Well, we need to put that $87 somewhere. So what label's on 87? Well, it's money. So again, that's going to be going in for the y variable. Okay, so I'm going to circle the variable that it goes in for. So I have 45 plus 7x equals 87. Okay, so we need to work on getting that x variable by itself. It has a coefficient of 7. We need to undo the 45 first by subtracting. Okay, 87 minus 45 is 42. And then we're going to divide by 7 on both sides. And 42 divided by 7 is 6. So 6 months. Okay, my next problem. This one's going to be a lot different. Okay. Golf club members have to pay a $350 membership fee plus a cost of $3 per round they play. Non-members have to pay $10 per round. How many rounds of golf would you have to play in a season to make the membership worthwhile? Okay, so I'm finding the rounds, and this again is 2 units, but here's where there's going to be some different things. Rounds, and then the other unit's money. Okay, now there is no time unit, okay? If there's no time unit, whatever you're paying the money for, which should be rounds, that's going to be your X. And then money's going to be the Y. Round, whatever I'm paying for, kind of whatever the product is I'm buying takes place, and that's going to be our X unit. Okay, so per dollars per round. Again, it's per, and the ratio needs to be the Y unit over the X unit. Otherwise, it doesn't make any sense. Okay, the cost per round, well, here's the problem. There's 2 different costs per rounds. We have $3 per round, so I'm going to put 3, comma, and we also, if you're a member, you have to pay $3 per round, and if you're a non-member, you have to pay $10 per round. Now, what I'll see a lot of people do is they'll add the 2 together and say it's 13. No, it's not. You need to keep them separate because you're either a member or a non-member. You're not going to be both, okay? So there's 2 rates of change. So what that means we're going to do is we are going to make 2 graphic representations instead of 1. Okay. So I have x comma y plus mx y, x comma y plus mx y. Okay. All right, so I know my 2 m's. I'm going to put $3 for this m, $3 per round, 3 times x, 3 times rounds, and I'm going to put $10 for this. All right, now before I paid $3 per round, how much money did I have to pay to begin with? Well, $350. Okay. Before $10 per round, how much money did I have to pay? Well, there is none. Okay, because you wouldn't have to pay that membership fee, so it starts at 0, 0. Okay, now here's how you write an equation from 2 lines. Okay, you want to know when the membership's worthwhile, and that basically is asking when are these two going to be equal. Okay, I'm going to put equals question mark. After how many rounds, how many X's are the cost going to be equal? Okay, so what you do is, how much money did you have to pay here? $350 plus 3x. But instead of equals y, we're going to go to the other line. How much did you have to pay to begin with? You didn't have to pay anything. And then the 10x. Okay, so you're really not going to use y. And you don't really need, you have everything you need to know in this equation. You're not going to replace anything. Okay, we're just going to get the x's together on the same side because we have multiple terms of x here on opposite sides. So we're going to balance the equation. Now, I know I always I'm going to get rid of the 3x, because if I get rid of 10x, there's not going to be anything over there, and I might get confused. Okay, so let's subtract 3x. And I have 350 equals 7x. And then we're going to divide by 7, divide by the coefficient, because you just have the 7x. There's no adding or subtracting to undo. And 50 equals x. Okay, so we're going to have to play 50 rounds. That's why if you play a lot of golf, you get a membership. Okay, here's the next one. Bill has $400 in his account and he's saving money at a rate of $15 per month. Chad has $1,200 in his account but spending money at a rate of $35 per month. Spending money, okay? That's for how many months will the two costs be equal? Okay, so we're finding the months. Okay, units rate of change. We have months, that's the answer to my problem, and money. Again, we have a time unit of months, so that should be my X representation, and then Y here. So per, I've got dollars per month. Okay, but again, there's $2 per month because there's two different people, so we have $15 per month for Bill, dash. And then for Chad, we have $35 per month. Now, one of these is negative because one guy's saving, so that's positive, but the other guy's spending. So how much he has, that needs to be a negative, okay? All right, so since there are two separate ones, we're going to be making two lines here. And we have our beginning. Plus mxy plus mxy. Okay, so I know my M is 15 for the first individual, $15 per month, and the other one's negative 35 because he's losing it, so negative 35. Okay, so prior to the $15 per month, this individual had $400, so that starts at 400. And the starting amount for this individual is $1,200. Okay, so again, after how many months will the monies be equal? So I'm going to put equals question mark because that's what we want to figure out. So I start with this line. We have 400. And then we're adding $15 per month to that. 400 plus 15x. But instead of equaling y, I'm going to go to this line. I'm going to put equals 1,200 plus negative 35x. You can also put minus 2 if you want. Now again, we have multiple variables here, so we have to fix this little problem of having two x variables. So again, they're on opposite sides, so we're going to balance the equation. I'm going to add 35x. On a story problem, I kind of like to balance the smaller one, so negatives. Plus 35x. So I've got 400 15 plus 35 is 50x, and then equals 1200. Okay, so here's my x term with a coefficient of 50. We have to undo the 400. So 50x. 1,200 minus 400 is 800. Divide by 50. Divide by 50. And that is going to be 16. Okay, so 16 months. Okay, now, here's the next problem. A racetrack charges a one-time startup fee and a cost for each race at that track. After 4 races, the racer will have paid a total of $195. After 10 races, that same racer will have paid a total of $375. How much will 25 races cost this person? So we're finding the costs this time. So cost is an important unit, and then the races that I pay for are another important unit. So we got money and races. Okay, so there's no time there's no time unit, but what is it that I'm buying? What is it that I'm paying for? What's the product I'm paying for? Races. So races is X, and then the money's Y, because the money's dependent on the races. Okay, and then per, dollars per race. Okay. Now, we run into an interesting thing here because let's read through that, kind of jot through that problem again. Do I know how much a race costs? The dollars for a race. Just one race. I don't think you do, because it says $195 for 4 races, $375 for 10 races. Now, here's what some people say. They'll be like, well, can't you just figure that out if you divide 195 by 4? Okay, so 49.5. But if you try to divide 375 by 10, oh, it wound up different. The reason they're different is because of this startup fee that they're talking about. That's what's throwing the problem in for that. Okay. So to find the dollars per race, because you know there is a cost per race and everybody would have to pay it. Okay. It would be constant. So the way to calculate it is to use y minus y, x minus x. Okay, so my y label is money. So find the two money amounts we have in the problem. 195 and 375. Okay, and you can put them in any order. I'm going to put I'll put 195 first. 195 minus 375. And then with 195, how many races was that for? That was for 4. And then how many was with the 10? How many was with 375? 10. All right, so let's go ahead here. So I take 195 minus 375. I get negative 180. And 4 minus 10 is negative 6. So I divide those and it comes out to $30. So 30. Okay. All right, so now I make my graphic representation. So x comma y, and there's only one rate of change, not 2. You don't make 2 lines here, okay? Because the reason why is because there's only one rate of change, okay? $30. That is the rate of change. X comma y plus mxy. That should be getting into a habit now. And we know our m is 30. Now my question to you is, did you even have 30? Did you even know from reading this problem, just reading it, that the rate that every race was $30? I don't think you did, okay? So we really don't know without any races where our money started at. Now, it started somewhere because there's a startup fee, okay? You don't know how much it was. So to find the beginning amount, you're going to use the y equals mx plus b formula. I'm going to put a dot between the m and the x. And remember what we do when we're using that, we cross out everything but the B, but we need to list what's called a combination of the two units. Now, I'm going to give you a little piece of advice. For it to be a combination of the two units, they have to appear together in the same sentence. So, 4 races and $195 are in the same sentence. So are 10 races and $375. Use whichever one you want because they'll both work. I'm going to use the first combination. 4 races and $195. Okay, so races, that's the label, and races is X. Okay, so that's going in for X, and this would go in for Y. Okay, so 195 is, and these 3 things, okay, will be what I plug in for the numbers. So Y is going to be 195. M is going to be the 30 that we found up there. And then 4. So I paid $195. And how did I get to $195? Well, I paid $30 per race for 4 races. So I'm going to take 30 times 4. And that's 120. And then plus B. And remember, I like to put a 1 in front of the B and kind of circle that off. So 120, I need to move that to the other side. I need to undo that. It's a positive, so I'm going to undo it by subtracting it. That gives me 75 equals 1B. But since I have a 1, I don't need to put that. So I put 75. Okay. All right, now I can write my equation. I had $75. I paid a $75 one-time startup fee. And then 30x. It's $30 per race. And that equals Y. Okay, so now the final value in the problem is they're asking me how much will 25 races cost. So 25 races is the replacement value. Now races, what letter is races a label for? And that's X this time, so that's going to go in for X. Okay, so I'm going to circle the X. So I have 75 plus 30. Replace the X with a parentheses and put 25 in for it. And then the Y stays. Now, the Y is already by itself, so I just need to plug this into the calculator. And that's all you need. Or you can take 30 times 25 and then add 75. Okay, 75. But if you're going to put in the calculator, you got to do it all at the same time so it does the order of operations correctly for you. So it's 825. Okay. All right, and then our last problem. Again, this is you need to get in the habit of 2-unit problem solving. Bill has an account to set up to pay his cable bill. He starts with a certain amount of money in his account, and every month the company withdraws money from the account. After having his cable plan for 5 months, Bill has $1,465 left on his balance. After having the plan for 10 months, the bill has $930 left on his balance. After how many months will his cable bill run out? That means when is he going to have $0? Okay, so we're finding the months. Okay, so months is our first significant unit. And then money. Okay, so remember what we talked about. Which one of these is my time unit? That's got to be the X. And then money's Y. And then per, the dollars. Remember the Y unit goes on top, and then per month. Okay, do I know the dollars per month? Nope, I don't think I do. So as a result, I know every month the same thing happens. Okay, they draw when you pay cable, it's usually the same every month. So again, I use the Y minus Y, X minus X situation. Okay. All right, now y minus y. Well, y is $1, so the dollar amounts I have are $14.65 and $9.30. Okay, so $14.65 minus $9.30. In the meantime, how many months are with the $14.65? Well, that would be 5. And how many months are in the same sentence as the $9.30? Well, that would be 10. Okay. Okay, so you want to use your calculator to be precise. 1465 minus 930 is 535. And then 5 minus 10 is -5. Now, you're going to get a negative here as your rate of change. And you're like, well, that doesn't make sense. Well, actually, it does. -107. So it's -$107 per month. Yeah, it does make sense because he fills his account and he pays money out of it, so it's going down. Okay, so the rate of change being a negative makes perfect sense. Okay, now we're going to make our line representation, just one, okay? Because there's only one rate of change in this problem. Remember, if there's two different rate of changes, you make two lines. But there's only one here. So x comma y plus mx y. Okay, so I know my m value is -107. Okay, that's well established. Now, since I did not have the -107 to begin with, I really don't know where this account started, but I know it started somewhere because to go down, it's got to start up there somewhere. Okay? It doesn't make sense for something to start nowhere and then go down. Okay? It's got to start up there somewhere, so it goes down. Okay? So, y equals m dot x plus b. Okay? And remember, I'm replacing these three letters, and I know what the m is. It's the -107, but I need to know a combo I can use for x and y. Remember, it's got to be one of each unit, and they have to go together in the same sentence. So again, we could go at 5 months and 1465 are in the same sentence, so are 10 and 930. I'll go at 10 and 930 because those are a little bit smaller numbers. So 10 months. And I like to put their labels too, so I know exactly where to put them. So 10 months, that would be my x, and that would be my y. Okay, so y is going to be 930. And then m's -107. And then we're going to be timesing that by 10. Okay, so I have, that's -107 and 10. So I have 930 equals, and I take -107 times 10, -1070, plus b. Remember to put a 1 in front and just circle it off. Okay, so you need to undo the -1070. So you're going to undo it with inverse operations. You're going to add it. I believe that's 2,000. Okay, let's check to make sure. Yep. Okay, and you don't need to divide by 1. So 2,000 is the beginning amount. Okay, so I had to work hard to kind of get my rate of change in my beginning amount, but that's what we got. Okay, so I have 2,000. I'm going to add -107x, or you can minus 1, just put -107x. It doesn't really matter. Either plus, negative, or minus equals y. Okay, now I need to come up with my replacement value in this one from this one line, and that's going to be the 0. Okay, so you want to know how many months it takes to get down to $0. The replacement value is kind of always your last value you're given. That doesn't come real easy to you. It's always the last value. Okay, so $0. Well, it goes in for y this time. So I'm going to circle y, and that's where I'm going to put the 0. So 2,000 plus negative 107x equals 0. And here's my x, coefficient negative 107. And we have 2,000, so we're going to minus that. That's going to be negative 2,000, so negative 107x equals negative 2,000. And then we need to divide by negative 107. And that's going to come out as into a decimal. That's okay, we're just going to say 18 then. Okay? So x equals 18. Because 19 months wouldn't be enough to pay. Okay, if you had me for Algebra 1, hopefully that came back to you. And if you didn't have me for Algebra 1, hopefully that made sense. Because you are going to need to use